Hi, after there, today I'm going to show you on the basics of matrix operation. So let's dive into the lesson. So definition, we're going to start by finding the definition of matrix. So this will be the same if you are given 1, 2, 3, 2, 5, 3, 1, 0, 8. This is the same as 3 rows and 3 columns. So it's going to be 3 by 3 matrix. And here given 2, 2, 1, 1, 3, 1. So it's 2 rows and 2 columns. So it's going to be 2 by 3 matrix. And here you are given only 1 row but 3 columns. So it's going to be 1 by 3 matrix. And here it's going to be 3 by 1 matrix since we are only given 3 rows. So definition of matrix is an array of entities arranged in rows and columns. This is the entities of arrays arranged in rows and columns. So let's go into addition and subtraction of a matrix. If we are given 2 by 2 matrix to add, so we are going only to come example here, it will be 1 plus 1 which will be 2, then 5 plus 0 which will be 5, 4 plus 1 plus 0 which is 4, and 9 plus 1 which is 10. If it were subtraction, you can also do the same. So if you add 2 by 2 matrix, also giving the answer of 2 by 2 matrix. Let's go on to multiplication of a matrix. Multiplication for matrix, we're going to using 7 method, because we're going to multiply row and the column. So it's look like 7. So you say let's say it's 7 method. So here we're going to, in case here we're going to multiply 1 by 2, 1 by 2, then 3 by 1. So it's 1 by 2 plus 1 by 2 plus 3 by 1, which will be give you 7. Then here it's going to be 2 by 2, which is 4, 1 by 2, which is 2, and negative 1 by 1, which is negative 1. If you add, you're going to get 5. This will be the multiplication of the matrix. So let's go on to transpose or adjoint of matrix. So for transpose or adjoint of matrix, if we are given this matrix, I asked to find its transpose. So we are going to change rows into columns. So for example, here we are given 1, 2, 3. So we change from this 1, 2, 3 from rows to columns. So it's going to be 1, 2, 3. And 4, 5, 6, we change it from rows to columns. So it will be 4, 5, 6. So we are changing rows to columns. For entities of the matrix or unit of the matrix, only the major diagonal will be 1 and other entities will be 0. For example, 2 by 2 matrix, major diagonal will be 1, 1 and other entities will be 0. For 3 by 3 matrix, major diagonal will be 1, 1 and the other entities will be 0, 0. Also by 4 by 4 matrix, major diagonal will be 1 and other entities will be 0. Inverse of a matrix. For inverse of a matrix, if you multiply inverse of a matrix by matrix, you always get its identities like this. If it were 2 by 2 matrix, if you multiply its matrix by its inverse, you're going to get this identity. For 3 by 3 matrix, you will get this one. And for by 4 by matrix, you will get this unit matrix. Let's go on to matrix of minor. Matrix of minor, we omit the column and the row, and the left element is the minor of the matrix. For example, if we are given this matrix, we are asked to find matrix minor. So we're going to, for 2, we are going to ignore the row and the column, so it will be 4. For 6, we are going to ignore the row and the column, it will be 1. For 1, we are going to ignore the row and the column, it will be 6. And for 4, we are going to ignore the row and the column, which will be 2. And this is the minor matrix of this matrix. For matrix cofactor, this we are going to multiply matrix minus and array of signs. For example, for 2 by 2 matrix, because we already find here the matrix of minor, so we are going to multiply it by array of sign, which is for 2 by 2 it will be positive, negative, positive, positive. You know that for 2 by 2, major diagonal will be positive and minor diagonal will be negative. So 4 by this one will be 4, 1 by negative 1 will be negative 1, and 6 by negative 6, and 2 by positive 1 will be 2. Thank you for watching my video. Welcome for the next class, which will be solving 3 by 3 matrix, 4 by 4 matrix for simultaneous equation using inverse or Grammar soul. Bye bye.